we just kind of need a refresher on a few things. First thing I want to remind you is how to go back and forth between exponential form and radical form. If I say like the cube root of x, you could write that as x to what power? 1/3. This is like a 1 here, so it's a 1/3. This number outside the radical is what always goes on the denominator. So if I said like the 5th root of x to the 4th, you would write that as, if I said this, how would I write that? Over 2. If I don't have a number outside the radical, it's assumed to be a 2. Okay, so that's how to go back and forth between radical and the exponential form. So the first thing I want to do is just take some problems and see if we can simplify them without a calculator. Okay, we're starting with numbers. Now I say without a calculator because if I give you variables, your calculator can't help. So while you could use your calculator to check your answer, I want to practice on some that we can actually think about and work out first. Okay. So if I said 16 to the 3/4 power, if I want to write that as a radical, what number goes outside the radical? 4. Okay, and then 16. The cube, you can put it under the radical or outside. It doesn't matter. So if I'm going to work this by hand, I'd probably prefer to do it the second way because I don't want to cube 16 in my head. So the 4th root of 16, that means what number to the 4th power equals 16? 2. 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16. So this 4th root of 16 is a 2. And then we just have 2 to the 3rd power, which is 8. Okay. Let's try some more. So B, the cube root of -64 to the 4th. So the cube root of -64, that's like saying what number to the 3rd power equals a -64. First of all, would that number be a positive or a negative? A negative. You know, -2 to the 3rd would be -8. -3 to the 3rd would be -27. -4 to the 3rd. 4 times 4 is 16 times 4 is 64. Do you guys know how to put these in your calculator if you needed to? If you look, like let's say I want to do the 4th root of 81. You hit the 4, and then if you go into math, you would do the 5th one, and that turns it into a 4th root, and then you could type in your 81. So if you needed to check it that way, you could. You know, if I'm doing the cube root of -64, it does tell me that is -4, so you can definitely use that to double check. So -4 to the 4th, keep in mind that 4th power applies to the negative as well. So this is going to give me a positive 256. Okay, C. You have to remember a few exponent rules. If you have a power to a power, what do you do with those? Multiply. So 3/4 times 2 is what? I'm going to write that as 3/2. So if I wanted to write that as a radical, that's telling me I have the square root of 25 to the 3rd power. What is the square root of 25? So then 5 to the 3rd is 125. Why don't you guys try D? Radical form, what goes outside the radical? The bottom goes on the outside. So the cube root of -8 is -2. And -2 to the 5th, -32. Alright. So far, so good? Let's look at some with variables that you can't just put the whole thing in your calculator to evaluate. Okay. So my goal here is just to simplify this as much as I can. So the 5th root of x times the square root of x cubed. Looking at it in radical form, it's really difficult to figure out how I would simplify that. But if I rewrite this, the 5th root of x, that's just next to the 1st, I would write that as x to what power? 1/5. Okay. The square root of x cubed, that would be x to the 3/2 power. Now, when you're multiplying, if the x is written each time, what do we do with these exponents? Add them. We need to do with the 1/5 plus 3/2. If you need to use a calculator on that, you can. So what do we get? (17/10). So my answer is x to the 17/10 power. You could certainly, if I asked you to write it as a radical, I didn't in the directions, but if I did, what would you put? Perfect. So either way. Alright, I'm going to do C with you, and then I'm going to have you guys try B and D. So this one looks a little uglier. I have a cube root over the entire thing. A cube root is like what kind of power? Okay. Then on the inside I have an x squared times, how would I write the 7th root of x? So starting on the inside, these are multiplied. The x is written each time, so you add those exponents. So 2 plus 1/7 . Okay, then the 15/7 and the 1/3, what would I do with those? Multiply them, yep. If the x is written each time, you add them. When it's a power to a power, you multiply. And that would give me x to the 5/7 power. you guys try these two for me. Okay. The first one, how would I rewrite the cube root of x to the fourth? Alright, times. How would I write the fourth root of x to the fifth? Then, since the x is written each time, what do we do with those exponents? Add them. So, 4/3 plus 5/4. Is that okay? Second one. All of this is under a sixth root, so that would be a 1/6 power. Inside I have x times the cube root of x squared, that would be x to the 2/3. Since these are multiplied, we add their exponents. If there's no exponent written, it is assumed to be a 1. So 1 plus 2/3 is 5/3 times 1/6. So we have x to the 5/18. Questions there? So that's half this section. The other half has to do with finding the domains of radicals. So if I have a root function, when I find the domains, there's essentially two groups. There are even roots and there are odd roots. Okay, with an even root, the radicand, which is the thing under the radical, has to be greater than or equal to 0. So if I'm doing a square root, a fourth root, a sixth root, whatever's underneath that has to be greater than or equal to 0. Odd roots are really nice because you can do the cube roots of positives, you can do it of negatives, you can do it of 0. So if it's an odd root, it's an automatic negative infinity to positive infinity. You can put anything in the world under an odd root. Well, let's look at some. So for the first one, is this an even or an odd root? Even. It's a square root, that's even, so you just take this thing under the radical, greater than or equal to 0. So we have 4x is greater than or equal to a negative 12, x is greater than or equal to negative 3. To write that in interval notation, that says it's everything negative 3 and bigger, so you do bracket, negative 3, comma, infinity. What about B? Right.
May I have your attention, please?
It's an odd root, so what does that mean my domain is automatically? And that's it. Okay, there is one situation where it may be a little harder. If I said find the domain of the square root of 36 minus x squared. This is one where you have an inequality with it. The problem is with that square, it's not quite so simple just to solve it. We've done those, but I think there's one on the Math Excel and it says to solve it analytically. That means looking at a graph. So we can get these from a graph. You would put in the square root of 36 minus x squared. And if I graph this, we see it's like a semicircle. Where does this one start? You can see -6, and it ends at +6. So if it was one that had like a x squared or something and it was a little harder to tell, you could certainly get the domain from a graph anytime, really. Okay, last two examples. I just want to remind you of some of your transformations. So if I wanted to graph y equals 4x plus 12, we're not even actually going to graph it. I just want to identify what the transformations would be if we did need to graph that. My recommendation is to factor this as much as you can first. What could I pull out of here? A 4. Now to bring it out of the radical, it's still a square root of 4. And we have an x plus 3. Yeah, so that becomes a 2 radical x plus 3. So then my transformations, the 2 is a vertical stretch by 2. And what's the plus 3? Left 3, good. So if you had to do transformations, factor that radical if you can. Last one, same thing. If I said the cube root of -8x plus 8. Okay, so if I take out the -8, that would leave me with the positive x minus 1. Cube root of -8. Since it's a negative under the radical, it just becomes a -2. If it was a square root, then it would be imaginary, but it's okay because it's an odd root. So we have a -2 cube root of x minus 1. So what does a negative do? The 2, just like the last one, is a vertical stretch. What's the minus 1? And what would make this one doesn't have it, but what would make my graph move up or down?
Like +5.
Yeah, if I had like a +5 outside the radical, that would be what would move it up. Okay. Any questions there? We have a lot of time left. You have a Math Excel assignment. It seems a little longer, it's like 19 questions, but there are some really easy ones, like the square root of 121, the cube root of -8. So it should go pretty quickly, and you've got a lot of time to work on that right now, and hopefully